Okay, guys, let's have a look at this. This is a case where we talk about two straight wire having the currents flowing through it. I don't know whether the currents are same or opposite, but actually you kind of remember the result already, which is good if you do. Now the part A is asking you to draw the magnetic field, is it? Yeah, draw 3 magnetic field lines on this with arrow. So this is having a current going in which direction? A battery is connected to T1 and T2. Yeah, vertically down. So this is top view, right? Yeah. Looking down. So yeah, top view. So in this case, moving down. So you grip like this. So this is correct. I would say, if you can tell me, when you guys draw the circle, can you tell me one thing that you want to pay attention? Other than, of course, the circle and the direction should be like this. What else? The distance of what? Between the circles. Very good. So if I want to make it so exaggerated, I can try to do it here. Let's say this is a wire. So the first one may be close to it, and the second one, and you want to show the difference, that the circles are getting the same distance or what?
Different.
What? How different should they be?
Larger.
Further and further away, right? So the next one could be even larger. So that shows a much bigger difference. Yeah, then that would be definitely the best. So I think depending on marking scheme, I think this one's still pretty good. I can still see a little bit of difference, but try to make sure the circle is a complete circle. Yeah. It will be good. Part B. Use a variable resistor, the PD between this gradually reduce. How will this affect the strength of the magnetic field? Of course, decrease, because current decrease, B field also decrease. Direction of magnetic field, since only reducing the resistor, it won't change, so you can say safe or no change. C. The battery is now connected to terminal 3 and 4, as well as T1 and 2. Let's have a look 3 and 4 as well first. 3 and 4 is like this, and it said 1 and 2, so I suppose they are going in the same direction. I guess, in the same direction. There is a current, down for both wire. Very clear the question. And this causes the flexible wire to move, so like what we said about the forces affecting each other. And explain why this will move. So firstly, the wire is a current. Okay, the wire is a current / carrying conductor, which is good. Alright, a slash here. Not slash, hyphen, sorry. In a B field produced by what? What is this word? Rigid, okay, rigid wire. So there's a force acting on. Actually, it's pretty good. You have to specify what wire and what wire. Last time I used wire A and B, but here they use the word flexible and rigid. It's the same idea actually. But of course, the flexible one can only bend, but the other one can't. So you have got the main idea that you have got currents in the wire, and it will produce a B field. When we say B field, we use capital letter B. B field, produced by the rigid wire. So there is a force acting on. I think that should be enough. Actually, it should be enough. I'll show you the mark scheme version. State the direction of movement of the flexible wire. As you know, remember the result of last time. If they go in the same direction, then they will attract or repel. They will attract, right? Like the philosophical inspiration I told you last time. They will go towards each other. Lastly, the battery is replaced by one that delivers smaller currents, stating the effect that will have on the force. Isn't this the same as resistor? So much smaller force. Yeah, I don't think that's too difficult. If I add one more part, if I ask you, if I change a battery into a AC supply, what do you think? Very good. Yeah? Can you explain again, Anna?
Because if you change the other way, it just goes up.
Yeah, well, of course, actually depending on how I connect the AC, but let's say if they both go down and both go up, this is called AC, right? If they both always go in the same direction, it's always attracting. So actually changing AC doesn't change the force, it's always still attracting all the time. Unless I say somehow they go opposite direction. Okay? Any questions about this? If not, I'll show you the mass scheme. So you can see concentric, of course, has to be.
Why can't we do both directions?
You mean this one? I don't know. I think they are just being linear. I have no idea, but yeah, definitely the one that we talk about must be correct. Just be strict yourself. Sometimes they are just very linear. I don't really like it. So these are correct. Yeah, these are correct too. Yeah, like what we said. Then it's nice. Okay, stop.